1 2 1 2 1 2 1 2 1 2. Woo! Hello guys and welcome back to this one. So today we are going to be jumping straight into the graphical illustration for the optimized approach for sorted first occurrence. Obviously this is just a sorted list, and then we are going to be going through it by divide and conquer in a sense, and eliminating certain parts where we know the value will not be, and then trying to locate it. So obviously we've defined our left and our right, and this is it. So our left is the index of 0, right is the index of 7, and then we go ahead to say what we define our target find to minus this and our t to be 14. So for the first instance, we look at the while loop. It says is L less than or equals to R. Obviously it is, because L is 0 and R is 7. So we check for the middle. We solve 7 minus 0 divided by 2, floor it. That's giving you 3.5. You floor it, you get 3, and boom, you get 3 as your final answer, because 0 plus 3 is still 3. So we then move ahead to say if t is greater than am. So if t is greater than, that's the value at the index of 3, the value at the index of the middle m, then if t is greater than it, then we run this line of code. We say L should move to m plus 1. So we take up L over here and move it to m plus 1, which is going to be 4. Now, having done that, what do? We say else if t is less than a. Right, so basically, we go and start from the top again, and we say, okay, L is less than or equals to R. Yeah, that remains true because 7 is greater than 4. So we solve for the middle again. We say 7 minus 4, giving us 3, divided by 2, 1.5. Then floor it 1, add that to 4, we get 5. So our middle is this guy. So having found our middle, then we check t's location. T is t greater than the middle? Nope. Is t less than the middle? No. Is t equals to the middle? Yes. So basically we come here, we update data find with 5, because that's the value of t, target find rather, not data find, equals to m. And yeah, we then go ahead to say r equals to 1 minus m. So that means we're moving r from here to where 4 is, or to where left is. So we come again and we check, is L less than or equals to R? Yes, L and R are equal, because the two of them now are pointing to 4. So we run again, we check where M is. M, after being calculated, would land us basically where the two of them are. So them are like, their middle is going to be them, because there's no difference, there's no variation between the two of them. And then we check, is T greater than AM? T, yes, is greater than 11, because M is now pointing back at 11. So what do? We move L forward. So we take L right here, and then we'll move it forward to this is M, so M plus 1 is here. So once we've done that, we break the loop and we then try to compare, is the two of them equal? Right? Is the two of them equal? Or is L less than or equal to R? So basically that condition does not hold true anymore. So we come out here and print 5, which is our target find, which is what it asks us to print here. So basically that's the solution. We see that it's no longer an ADT, not a heap, or let's use a heap. Basically now we are going into thinking and understanding through the solution, right? Bringing up an algorithm that will help us figure out, oh, this is the best approach. We saw what the brute force was. It was just basically going one at a time. But this guy is basically eliminating places that the value we are looking for can never exist. So that's the algorithm. See you on debugger tools. Muchas gracias. Ciao.